let's see system of units. A system of unit is a complete set of units. Okay, the first point is complete set of units. Both fundamental and derived of all kinds of physical quantities. Okay, complete set of units, both fundamental and derived. Both fundamental and derived. So what is a system of units? This is a complete system or complete set of units which may be fundamental, which may be derived. Okay. Some common types which are used in mechanics are there are many, but let's learn about four major, and they are, first one we can see FPS system. FPS system, it means foot, pound and second. What is this foot? This is for length. This is mass. Pound is used to measure mass, and second, this is used to measure time. This is a system of units. FPS is a system of units in which we measure length by foot, mass by pound and time by second. Okay, another one, let's see CGS system. CGS system, this is in fact a Gaussian system. This is a Gaussian system. CGS is a Gaussian. This is a British system. This is British engineering system. FPS is a British system, and this one is a Gaussian system. Gaussian, double S, Gaussian system. The name suggests CGS. It means it is centimeter, it is gram, it is second. We use centimeter for length, and we use gram for mass, okay, and second for time. Okay, now we enter the third system of units, that is MKS system. MKS system of units. Here the name suggests MKS, meter, kilogram and second. Okay, so here it is meter, it will measure length, and kilogram, it will measure mass, and here it is second, it will measure time. This is MKS system. It is considerably followed, but today internationally we follow another system of units which is called SI units. SI units. SI units. This is internationally followed. This is internationally followed And this is internationally followed for what? For measurement. For measurement. Internationally followed for measurement. In French, you can write it as System International Unit. So it is abbreviated as SI units. This is an abbreviation. Abbreviation of what? Abbreviation of System International Units. Okay, in French. This is French abbreviation. Now we will learn SI units in more detail, as this SI unit is used internationally for doing any type of measurement or any type of business dealings or any type of commercial or any type of scientific. It is internationally accepted. Therefore, we will learn SI units in detail. Okay. Now let's see. Let's see SI units in detail. SI units. There are seven. There are seven base units and two supplementary, you can say also. There are seven base units. In SI units, there are seven base units, and two supplementary units. We will see it also. Supplementary units. For internationally accepted units, there are seven and two supplementary also. The seven base units are here we write length. To measure length, it is meter. To measure mass, it is kilogram. We can write symbols also. Symbol is M. Symbol what? kg. And to measure time, here it is second. Symbol is simply S. Electric current. What is the unit? Ampere. Ampere, abbreviated as A. And temperature. What is the unit? Kelvin. Abbreviation K. These are physical quantities. This length, mass, time, electric current, temperature, amount of substance. Amount of any substance. It is measured in mole. Its abbreviation is simply leave one letter E, mol. And the last one is luminous intensity. Luminous intensity. This is candela. Unit is candela. Abbreviated as CT. Okay, so 1, here it is 2, 3, 4, 5, 6 and 7. These 7 base units. Okay, 7 base units, 7 physical quantities, 7 base units and their abbreviations. And we have also seen that there are 2 supplementary units. What are these 2 supplementary units? These supplementary units are used for what? For plane angle and solid angles. For measuring, supplementary units are used to measure what? Plane angles, plane angle. Plane angle is measured in radian. Radian, the symbol is RAD simply. Okay, and what you can start about plane angle. Suppose we can say that there is one angle, there is a circle. This is a circle, suppose that, and this is a radius, this is angle theta, or you can write d theta. There is change in the angle. This is O, the center, and this radius is equal in length with this arc only, this arc. This is also R. Then the angle subtended will be equal to then the angle subtended will be called plane angle. Okay, 1 radian, that is called 1 radian. This is a plane angle because this angle lies on a plane. This is not a 3-dimensional. This is only 2-dimensional. This is lying on a plane, and here S will be equal to you can say ds. R will be equal to ds because the ds is the radius. Arc length, and so we can write d theta equals to ds by r. Here we see that 1 radian, for 1 radian only. This is for 1 radian. This completely for 1 radian. 1 radian, you can say the angle subtended at the center, this center of the circle, by an arc equal in length to the radius. This one is an arc. This is equal to the length of the radius, and then the angle subtended will be 1 radian. Okay, this is a general formula. Now we can say solid angle. This was the first supplementary unit. Second supplementary unit is solid angle. Solid angle is measured in asteradian. Asteradian. It is abbreviated as SR. Okay. Solid angle. The name confirms it is solid. The angle subtended at the center of a sphere by the surface of the sphere, which is equal in area to the square of the radius of the sphere. You can see here, suppose this is a spherical ball. Okay, a spherical ball, and the angle, this is center of the spherical ball, and there is one angle formed at the center which by the surface of this ball, and that amount of surface which is equal to the area subtended by what? R square. This area, angle subtended by this area at the center, is a solid angle. Okay, this is a solid angle, and this area will be equal to R square by radius. Okay, that will be 1 asteradian. Okay, Its general formula can be written as d omega equals to dA cos theta by r square. Okay, let's see. Let me write down for notes purpose. D omega equals to dA cos theta by r square. What is r? R is the radius, whose radius, this is a spherical ball, and this is a spherical surface which is making this solid angle, and the radius of the spherical ball, that is r. And what is this A? A is the area of this small part which is subtending the angle at the center. Okay, this A, and R, you can understand this is the term used to find out the solid angle. Okay, now let's see the next, that is next topic. The next topic is rules for writing SI units. Rules of writing SI units. This is important mainly in board exams. This question comes in theoretical. Okay, for theory purpose this is important. The first rule is small letters are used for symbols of units. You can remember small letters are used for symbols of units. For example, you can see, if you see for meter, what is written? For meter, what is written? It is m. Kilogram, what is written? Kg. So small kilogram, what is written? Kg. Small letters, not capital K. Okay, symbols are not followed by a full stop. Remember, this topic I am teaching is primarily used for theoretical questions. Symbols are not followed by full stop. For example, let's see, suppose we write 5 kilogram. Suppose we have to write 5 kilogram. Then how we will write 5 kg? Here we will not put any full stop. Okay, simply we will leave. And although it is the last part of the, if we are writing 5 kg in the last part of the sentence, we will use this full stop, but this full stop will be used to end the sentence, not to end the unit. Okay, a unit is not followed by a full stop. You can remember it only. The initial letter of the symbol is capital only when the unit is named after a scientist. If unit is named, this is important, named after a scientist, then initial letter will be capital, then initial letter will be capital, then initial letter will be capital. For example, do you remember Tesla? Unit T. T is abbreviated. This is capital letter. This is the name of a scientist, Tesla, and the initial letter, that is capital T, one letter. Faraday, it is capital F. Joule, it is capital J. These are all scientists. Okay. And the next point is the full name of a unit always begins with a small letter, even if it is named after a scientist. You can see full name of unit always begins with a small letter, always begins with a small letter, even if it has been named after a scientist. After a scientist. What does it say? Full name of a unit always begins with a small letter, even if it has been named after a scientist. Suppose the unit contains the full name. Suppose the unit contains the full name. Can you tell the example? Suppose the unit contains the full name. If the unit contains the full name, it will not, the full name, the first letter will be a small. You have to remember only this. Okay. Full name of a unit always begins with a small letter, even if the, can you remember Newton? Force, unit of force is Newton. For example, we can say Newton. Suppose Newton is used, that is only one symbol, that is capital N. If we write 5 Newton force, 5 Newton force, okay, and in any way we written it 5 Newton force, okay. This Newton is used as a unit, okay. This Newton is used as a unit, so this will be written as 5 Newton force. If this Newton will be used as a unit, the full name of a scientist Newton, it will begin with a small letter, okay. This is a rule of writing SI unit. Okay, the last one is symbols do not take plural form. Symbols do not take plural form. Plural form nahi. Plural form, they cannot take plural form, that is we cannot write 5 say CMS, okay. We cannot write 5 CMS, we can write only 5 centimeter cm, okay. We cannot write 5 sorry, we can write it as 1 centimeter, 2 centimeter, 3 centimeter, not centimeters. S we will not write any S. Okay. And one more topic, that is an important theoretical topic, that is a question comes in the board exams, that is advantages of SI units over other units. Now we see the advantages of SI over other system of units. The first advantage is SI is coherent. You must remember it. Coherent system of units. Coherent system of units. It means that it can be obtained by simple multiplication or division of fundamental units without introducing any numerical factor. Okay. Coherent means what? Coherent system of units means can be obtained by simple multiplication or division. Simple multiplication or division. Simple multiplication or division of fundamental units. Okay. Another point is SI is a rational system of units. This is rational. What does it mean? It means that it uses only one unit for a given physical quantity. It means, what does it mean? It means that it uses only one unit. It uses only one unit for given physical quantity. For a given physical quantity. For example, you can say energy. For example, you can say energy. Energy is measured in joule. Okay. On the other hand, in MKS, in contradiction, you can also read, on the other side, you can say in MKS, what happens? In MKS system, mechanical energy is measured in joule, heat energy is measured in calorie. Mechanical energy in joule, heat energy in calorie. Also electrical energy in watt hour you can write. So in MK system, different energy forms have different units, and in SI unit this is rational. It uses only one unit for a physical quantity, that is energy, only joule, no any other unit. Okay. Now SI is a metric system. SI is a metric system. What does it mean? It means multiples and submultiples of SI unit can be expressed as powers of 10. Okay. It means that multiples and submultiples can be expressed as powers of 10. This is metric. Metric means multiples and submultiples can be expressed as powers of 10. Powers of 10, that is what? And that is what? A into 10 to the power plus minus b. That is, in this form we can express it. This is power of 10. Simply we should remember it can be expressed as powers of 10, so it is metric system. And the last advantage is SI is absolute. It is absolute. Absolute. What does it mean? Absolute. It does not use gravitational units. Okay. The use of small g is not. Absolute system of units. SI is absolute system of units. Does not use gravitational units. Gravitational units is what? This G. Okay. Thank you.